Because now we're moving to inductive reasoning. Okay, inductive reasoning is basically when we see patterns. We see things happening over and over again. A couple of days ago was sunny. Yesterday was sunny. Today is sunny. So guess what? I'm gonna guess that tomorrow is gonna be sunny. Could I be wrong? Of course. But I'm looking at patterns. I'm looking at repetition. Right. So based on specific cases, because I said yesterday, 2 days ago was sunny. Yesterday was sunny. So I was looking at specific cases. I'm gonna generalize on an idea. Tomorrow is gonna be sunny. Next week is all gonna be sunny. Why? Because I look at previous things. So we call those in mathematics, we call that pattern. Now here, let's take a look. It says find the term name in the problem. So my first number is the 13. So I have a list of numbers. Then I have a -17. I have a -47, a -77. So it seems like I'm subtracting, right? Because it's getting smaller and smaller numbers. So I'm subtracting. And now here it says find the 40th numbered on the list. So a couple ways I can do this. First of all, let me see. So it seems like I'm subtracting. Or I could be dividing for all I know. Let me see. What am I doing? So from 13 to get -17, I have to subtract, right? How much do I have to subtract? Well, I have to subtract 30, right? 13 minus 30 gives me -17. For the next one, from -17 to -47, it gets a bigger negative, so that means it gets smaller. Have to subtract as well. How much do I have to subtract? Have to subtract 30 as well. Okay. What about on the next one? Well, I have to subtract 30 again. So, okay, so we just found out that on my list here, for each of my numbers, I have to subtract 30 to get the next number. I have the first four. I'm trying to find the 40th number. So I can find the fifth number, sixth number, and I can go on and on and on until I get the 40th numbered on my list. That's doing it the long way, but that is one way of doing it. Right? It might take us a long time, but eventually we're gonna get to the correct number. Another thing I could say is, let me use logic on this one. Let me see what's happening. I start with the number 13, but then I'm gonna start subtracting 30, starting from the second number. So let me see real quick. I'm gonna say, I start with the number 13, but I'm gonna subtract 30, starting from the second number. So to get to the 40th number, how many times do I have to subtract 30? Keep in mind, I started subtracting for the second number, so not from the beginning. So in this case, I'm gonna say I have to subtract 30, 39 times. Again, I started subtracting from the second number, not the first number, from the second number. So yeah, I'm gonna go 13 minus 30, 39 times. So one, I can see -30 minus 30 minus 30, 39 times, but wasn't that just simple multiplication? Wasn't uh repeated addition or repeated subtraction? Wasn't that just multiplication? Now, so I have a multiplication and I have a subtraction. Remembered order of operations. Remember, we have to subtract after we multiply. So better yet, let me say this. We have to multiply first. Don't forget that. So I have to come over and be like, oh, what's 30 times 39? I'm going to use a calculator if necessary. So I'm going to go 30 times 39, and I'm going to find out is 1,170. Okay, so I have 13 minus 1,170. Now this thing is going to give me a negative 1,157. Cool. That's my 40th number on the list. See how I just saw what was happening? I started with 30, and then I was going to subtract 30, 39 times. Not 40 times, 39 times. And the reason why it's 39 instead of 40, because I started subtracting on the second number, not the first number, the second number. So I started subtracting from the second, so it's 1 less than 40. Okay, so let's take a look at here, number 8. Okay, so from 18 to 38. Now here I add, right? Because it's getting bigger. So how much? For 18 to get 38, wouldn't I have to add 20? Good. Does 38 plus 20 equals 58? Yeah. Does 58 plus 20 equals 78? Yeah. So it seems like I'm adding 20 and 20 and 20 and 20, starting from the second number. So I need to find my 25th number. So then I'm going to say, okay, for that, it's easy. I start with 18, and then I'm going to add 20 so many times. Okay, how many times? Okay, I need the 25th number, but I started counting from the second number. So not 25 times, 24 times. Good. My plus sign is what I'm going to do at the end. I'm going to do addition at the end. Have to multiply first. So I have 18 plus 20 times 24. That's 480. Now 18 plus 480, my answer will be 498. Beautiful. Okay, I'm working up until number 14. So let's take a look at question number 9. I'm still looking for patterns here. Here they want me to find the 11th number. Okay, so not that bad. So for 1 to get to -3, adding and subtracting was working. So it seems like probably I have to subtract 4. Right, because 1 minus 4 is -3. But is -3 minus 4 equal to 9? No, not really. 9 minus 4 equals 27? No, not really. Okay, so adding and subtracting is not always going to work. Okay, what else can I do? It seems like I get a 1. Let me ignore the decimal. It seems like I get a 1 and then a 3. I mean, let me ignore the sign. My bad. I get a 1, then becomes 3, then becomes 9, then becomes 27. Ooh, so it seems like I multiply by 3. Another thing that I notice is that the sign switches, positive, negative, positive, negative. So when I multiply by negative, that's going to make my sign switch. 1 times a -3 is -3. -3 times a -3 is +9. +9 times a -3, yeah, that's -27. So I just found out that it's multiplication this time. Okay, so I'm going to go 1 times -3, 10 times, right? Because remember, I start counting on the second number. So I need to find the 11th number. So I need to multiply this 10 times. Now, I'm not going to go -3 times 10. I'm not going to go, let me do this. I'm not going to go times 10. Let me emphasize, I'm not. Because -3 times 10, that basically means I'm going to, multiplication is repeated addition. So by doing that, I will say I'm subtracting -3 10 times. So no, it's not that. Remember, how do we write repeated multiplication? Do you guys remember that? Repeated multiplication. Repeated multiplication, it's an exponent. So I'm gonna write -3 to the 10th power. Okay, repeated multiplication is an exponent. Okay, I remember order operations, right? Some of you guys call it gems. Some of you guys call it PEMDAS. I remembered I have to do exponents first, and then I multiply. So -3 to the 10th. If you know how to use your calculator, you're going to use the caret, use the negative sign, use parentheses. Notice how I have my -3 in parentheses to emphasize is a negative. So -3 to the 10th, or literally you're going to go -3 times -3 times -3 times -3 10 times. So that's gonna give me 1 times, because that one I'm gonna deal with at the end, 1 times. Now -3 to the 10th gives me 59,049. Okay, so now to my last step, 1 times 59,049. I'm gonna call this 59,049. Not bad, right? Inductive reasoning, basically I look for patterns. Now here, what am I doing? Am I adding? So 3 plus 3 is 6, but then 6 plus 3 is not 12. This case, I'm multiplying. I'm multiplying by 2, right? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So I'm multiplying by 2. I'm finding the 10th number. So this thing I'm going to say, I started with a 3. My first number is a 3. And then I multiplied 2 9 times. Remember, I started multiplying from the second number. So it's not 10 times, it's 9 times. Okay. So I had to do my exponent first. Had to do 2 to the 9th. Remember, the way I will type this on my calculator is 2 caret 9. So 2 to the 9th. Boom. So I have 3 times. Now 2 to the 9th. What is that? 512. Okay, now 3 times 512 is 1,536. So that's inductive reasoning. Now, sometimes I will even tell you guys what's happening. What am I doing? If I'm gonna add, I want to call that arithmetic sequence. So let me come over here. Sometimes I'm gonna say arithmetic sequence. Sometimes I'm gonna use the word geometric sequence. Okay, now let me explain what that means. Arithmetic sequence, that means adding and subtracting will work. Okay, geometric sequence, that means multiplying or dividing works. So I will use those words, arithmetic sequence, geometric sequence. Now here, given two terms in an arithmetic sequence, find the term named in the problem. So there's a list of numbers. I have the 13th numbered on the list. I have the 38th number on the list. And I want the 25th number on the list. Well, let me see first of all, what was I adding or subtracting? Right now, because it's arithmetic, I know I was adding or subtracting something. Well, I need to figure out what that something is. We're going to call that difference. But I'm going to use these two numbers to figure out. Okay. So I'm going to say, okay, let me find the difference. What am I adding? What am I subtracting? Let me call it D. So the way I'm going to figure out what my D is, I'm just going to say 91, because that's the smallest numbered, plus D. Now, if I was adding, D is going to be positive number. If I'm subtracting, D is going to be a negative number. So on D, how many times do I have to add if I have the 13th numbered and I want the 38th numbered? Well, that's not bad. I have to add it 25 times. How did I get the 25? I just subtracted 38 minus 13. That's really how I got 25. And this is going to be equal to 341. Notice where I got these numbers from. So 91, I'm going to add the difference 25 times, and it's going to give me 341. Let me solve for D. Okay, let me solve for my difference first. Remember, algebra 1, I have to isolate the variable. So this plus 91, let me subtract this as a minus 91. So I have the D times 25 is equal to 340 minus 91. 341 minus 91 is 250. Okay, now let me divide both sides by 25. So I get that D is equal to 10. Now, I found a very key part of for my answer. I'm gonna be adding 10. That's really what I was told here. I would just find out that I'm gonna add 10. Now I'm ready to answer. Now let me change this to red. Okay, let me start with the 13th number and let me get to the 25th number. So the way I'm gonna do this, I'm gonna say 91, because that's that number I'm gonna start with. I'm gonna add 10, because remember my difference was 10. I'm gonna add 10 12 times. Well, from 13 to 25 is 12 times, right? I just subtracted 25 minus 13. Okay, so I have 91 plus, because I have to do multiplication first. 10 times 12 is 120. Now 91 plus 120 is 211. So find out what's the difference. What are you adding? What are you subtracting to be able to solve this question? Okay, let's take a look at question number 12. I'm gonna use these two numbers to find out what's the difference. What am I adding? What am I subtracting? And I want to say, well, I start with a negative 93. I'm gonna add the difference. Okay, so from 11 to 39, that is 28 times. Remember, I just subtracted 39 minus 11. That's how I got the 28. So negative 93 plus the 28 times gives me a negative 373. Again, if D is positive, I'm adding. If D is negative, I'm subtracting. To be honest, here, I will say D will end up being negative. It looks like I'm subtracting. So it is okay for D to be a negative number. Okay, so let's see. Let me solve for D. This negative 93, let me move it over as a plus 93. So I have that D times 28 equals. Okay, what do I do when I have the signs different? Well, I subtract my values, right? Negative 373, positive 93. The signs are different. I subtract the values. So 373 minus 93 is 280. And I keep the sign of the large number. So in this case, negative 280. Let me divide by 28. So my difference is negative 10. Okay, so I'm subtracting 10 each time. I'm ready to get my part here. I'm gonna use my 11th number on the list to figure out what the 27th number on the list. So I'm gonna say negative 93 minus 10, because I'm subtracting 10 this time, 16 times. Okay, where did that 16 come from? From 11 to 27. Subtracted those two values. 27 minus 11, 16. Okay, so I have negative 93 minus 160. Remember, I have to multiply first. So negative 93 minus 160 gives me negative 253. Cool, that's not bad. Now, get really good at this. In Algebra 2, you guys are going to see sequences again. This is part of Algebra 2 as well. Right, I'm solving for a variable that was algebra 1, right? So there's topics that we see more than one time. Now, geometric sequence. Ooh, geometric sequence, that means multiplication. Okay, so I'm gonna use, let me see which number I'm multiplying by. So I have the second number on the list and the third number on the list. Ooh, okay. So I'm gonna say second number on the list comes first, right? So I'm gonna say 9 multiplied. Let me call this R, because I don't know which number I'm multiplying by. So let me call it R for rate. Okay. How many times, if I have the second numbered, how many times do I have to multiply it to get to the third number? Well, only once. Right, from 2 to 3 is only 1. I really subtracted those two values. Okay, so 9 times r to the 1 is equal to negative 27. See how I use the second number and the third number? Okay. Let me divide by 9. So r to the 1 is equal to negative 3. So that means that r is my negative 3. So negative 3 is a number that I keep on multiplying. That's my rate. Okay. I need to figure out the 10th number on the list. It doesn't matter which one do I start with, the second number or the third number. It doesn't matter. Let me start from the second number. Let me use this, and let me use my rate to figure out my 10th number on the list. So I'm going to say 9 times negative 3 to the 8. Okay, because from 2 to 10, it's 8, right? If I would have started from the third number, so if I would have started from negative 27, I will multiply negative 3 7 times. Okay, so I have to figure out what's negative 3 to the 8th. And that gives me 6,561. Okay, so let me say this is 9 times, what did I say it was? 6,561. And then now I have to multiply this. What's 6,561 times 9? And it gives me 59,049. You guys will have to use this formulas in your homework. Make sure you guys get really good at it because you guys also have it in your quiz. Let's take a look at here. Let me find the rate first. I have the second number in the list and I have the 5th number in the list. The second number in the list comes first. So I'm going to say 6 times the rate 3 times. Okay, so now the 3 because I subtracted 5 minus 2. Right, the 5th number minus the second number. So 6 times r to the 3rd is equal to 162. Okay, let me divide this by 6. So r to the 3rd is equal to, now 162 divided by 6 is 27. Now I want to know which number multiplied by itself 3 times equals 27. I'm not going to divide by 3, okay? It's not 27 divided by 3. I'm asking which number multiplied by itself 3 times. So if you know how to use your calculator, use the cubic root. Okay, so which number multiplied by itself 3 times? So I'm going to say 3. So my rate in this case is 3. Okay, cool. I need to find the 10th number. Let me change this to blue so we don't get confused. Now, it doesn't matter if I start from the second numbered or I start from the 5th number. Honestly, I'm going to start from the 5th number because it's closer to 10. So I'm going to say 162 times. The rate is 3, right? So my R is 3. From 5 to 10, I only have to multiply this 5 times. So I have to figure out what's 3 to the 5th. And now 3 to the 5th is 243. This is 243. So let me do 162 times 243. Use a calculator if you need to. I end up getting 39,366. Beautiful.